All right, so we are going to do substitution on our limits of integration. So for this first one, I'm just going to do this twice so you can see what's happening. So I'm going to go from 0 to 1 of x to the third times 2x to the fourth plus 1 squared dx. So remember that your limits of integration are in terms of x. All right, so if I want to know what my u is 2x to the fourth plus 1, which makes my du 8x to the third dx. So what am I missing? I'm missing an 8. So I'm going to balance with a 1/8. Okay? So now I can rewrite this as 1/8 times the integral of u squared du. But here's the problem. My limits of integration are referencing x's, and I just replaced everything with u's. So those don't mean the same thing anymore. So we're going to backtrack for a second, and then I'm going to rewrite. But let's go ahead and finish this out first. When I return it into terms of x, I'll put my limits of integration back. So this is going to become u to the third over 3. So 1/8 comes along for the ride. I've got a u to the third over 3. So that makes that 1/24th u to the third. But I'm going to take this now from 0 to 1. Okay. So, oops, sorry, what's my u? 2x to the fourth plus 1. All right, so I evaluate with a 1 first. So I've got a 1/24th times 2 times 1 to the fourth is 2, plus 1 is 3, and 3 to the third is 27. Minus 1/24th, and then if I sub in a 0, I get 2 times 0 to the fourth, which is 0, plus 1 is 1. Okay, so I get 27/24 minus 1/24 is going to be 26/24, which is actually 13/12. All right, so I could have made it a little bit easier to start with, and since I'm going ahead and subbing in for u's and du's, I might as well sub in and figure out what my x's would be. So this is the key to this right here, when you tell me what your u is in terms of x. So if I want to go ahead and flop out my limits of integration in terms of x, I can figure out what they would be in u world. So if I evaluate this at 1, which is my upper limit of integration, so 2 times 1, okay, so 1 to the fourth is 1. 2 times 1 to the fourth plus 1 is 3. So my upper limit of integration in x world is 1. My upper limit of integration in u world is 3. Because again, my u would be 2 times 1 to the fourth plus 1, which is 3. So my lower limit of integration, I'm going to sub in a 0. So my u would be 2, 0 to the fourth plus 1 is going to be 1. So my lower limit of integration in terms of u goes from 1 to 3. Okay, so who cares? Because I can skip everything that I did here because all the hard work is done. Since I'm in u world and I converted everything into u world, I can leave it in u world. So what does that mean? Let's just rewrite for a second. I've got 1/8 times the integral from 1 to 3 of u squared du. So what's my integral? It's going to be u to the third over 3 times my lead of 1/8. But remember, you've already changed this into u's and du's, so use your new limits of integration. So this becomes 1/24th, and then 3 to the third is 27, minus 1/24th, and then u to the first is 1. Okay, so what did I get up here? I saved all of this back substitution in this mess, and I just dove straight to here. And so it kind of seems a little bit harder, but when you get further on into Cal 1 and especially in Cal 2, it's actually a really quick shortcut. So you don't have to waste your time in here. So either way, I still get 27/24 minus 1/24 is 26/24, which is still 13/12. So we've got two more of these, and I'm going to do them just based on U substitution. Okay. So my first one is going to be from 1 to 7 of 1 over the square root of 2x plus 2 dx. And I'm going to rewrite that as the integral from 1 to 7 of 2x plus 2 to the 1/2 power, but I brought it up top, so it's negative dx. So as long as I'm converting everything to u's, I'm going to convert my limits of integration to u's. So first of all, what's on the inside? 2x plus 2. 2x plus 2, which makes my du a 2 dx. So I'm missing a 2. So I'm going to balance with a 1/2. Okay? So I've got a 1/2 times the integral, and I'm not going to write 1 to 7 because I'm fixing to change them, of u to the negative 1/2 du. Now, put your upper limit of integration into u, or into your u equals. So 2 times 7 is 14, plus 2 is 16. Okay? 1 times 2 is 2, plus 2 is 4. So instead of having to back substitute, since we have a definite integral, I can just stay in U world and complete everything in there, but only if I substitute my limits of integration and change them to. So what do I have now? U to the negative 1/2 becomes U to the positive 1/2. Divided by 1/2 means times 2. So this 1/2 and this 2 reduce. So I actually have the square root of U evaluated from 4 to 16. Okay, so 16 square root of 16 minus square root of 4 gives me 4 minus 2 is 2. So I shoved in the 16, took its square root, shoved in the 4, subtraction. That became a 4 minus a 2 is 2. So the last one that we're going to do, same thing. I'm just going to leave it in terms of U. And if you would like to do it in terms of x, you can. So I have the integral going from negative 8 to 8 of x times 8x squared plus 4 to the third dx. So my u is going to be 8x squared plus 4, which makes my du 16x dx. I've got the x, I got the dx, I need the 16, so I'm going to balance with a 1/16. Okay, so 1/16 times the integral of u to the third du. So this is now u to the third du. Here's my du. And now just sub in here. So what is 8 times 8 times 8 plus 4? Or what is 8 times 64 plus 4? I don't know. Hang on. 8 to the third is plus 4 gives me 5/16. Okay, so take your upper limit of integration and now take your lower limit of integration. So I get 8 times, well, negative 8 times negative 8 is 64. So 8 times 64 is 512 plus 4 is 5/16. And now you can stop here. Your upper limit of integration and your lower limit of integration match. So if you'll think about that, what that means is I've got a cubic function that is being compressed. So he's way out like this. And that's my u cubed. And then I'm evaluating from 5/16 to 5/16. Which means it's 0 because you can't see. It's 0 because I don't have a beginning and an end. My beginning and end are the same. Okay, so if you had gone through all of this mess at the end and just reverted back and put everything in terms of x and then taken it from -8 to +8, done all the math and all this kind of stuff, what you would have figured out at the end is that it went to 0. Well, here's a little trick where you figured out right up front it went to 0. So your answer here is 0. And that is it. So again, if you leave it in terms of u, just make sure you change your limits of integration by substituting the upper limit into here, and then the lower limit into here. And then you can leave it in terms of u as long as you've got a definite integral. But you can always revert back and back substitute into x's and use your original limits of integration if you want to. And that is it for chapter 4. Try to find my mouse.